And you should be able, just give it a second to come up, and you should be able to see my OneNote. And we're starting with problem 6. Alrighty. Alright, so we're ready to go. So we want to find the area bounded by the curve y is equal to cosine x and the x-axis when x is equal to 0 and x is equal to pi. So the first thing that I'm going to do is I'm going to first start drawing out my cosine curve. Let me draw out a rectangular coordinate system. And I'm going to draw out my cosine curve in blue. Now this is a standard cosine curve. Y is equal to cosine x. Standard cosine curve. Now with a standard cosine curve, we'll have the values on our x-axis to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is a standard cosine curve. Now we're looking for the area bounded by the curves y is equal to cosine x and the x-axis. So the x-axis I'm going to highlight in red, like so. Now the area bounded by the curve I'm going to show in green. So we're looking for the area here, and we're looking for the area from 0 to pi. Therefore, we're also going to be taking the area here. Any questions so far on my drawing of my curves and of the area that we're trying to find? All right. So in order to find the area bounded by our curves, what we want to do is we want to take the integral of the upper curve minus the lower curve. Now notice that we have two areas that we're looking to find. Therefore, we're going to have two separate integrals. The first integral of the upper curve minus the lower curve plus the second shaded region, again, will be the upper curve minus our lower curve. Now just be careful when we're going to substitute into our integral. So in the first shaded region here, let's identify our upper curve. Our upper curve is going to be what I highlighted in blue, our cosine x. Now our lower curve in the first shaded region is what I highlighted in red, which is our x-axis. Therefore, our lower curve is going to be 0. Y is equal to 0. Now notice in the first shaded region, we're looking for the area that's bounded from 0 to pi over 2. So that's what we will be evaluating our integral at, 0 and pi over 2. Any questions so far? All right, now let's substitute into the second shaded region. So this is going to be plus the integral of the upper curve minus the lower curve. Now be very careful when we're highlighting our curves in the second region, because now our upper curve is going to be y is equal to 0 minus our lower curve, which is now going to be what I highlighted in blue, our cosine x. And we're evaluating this integral from pi over 2 to pi. Now remember, because we are evaluating an integral, we need to put our dx within our integrals. Okay, so let's put this in a set of parentheses and put this in a set of parentheses. All right. So now let's just simplify our integral, what we have inside of parentheses. I'm going to finish it over here on the left side. So we're going to have 0 to pi over 2. Cosine x minus 0 will just be cosine x dx plus the integral of pi over 2 to pi Now we're going to have 0 minus cosine x dx, so it will just be negative cosine x dx. Okay? Now let's evaluate our integrals. So the integral of cosine x is going to be sine x, and we're evaluating that from 0 to pi over 2. Now in the second integral, notice how we have the negative sign within our integral. So what I'm going to do is I'm going to bring the negative out. So when I take the negative out, the positive and the negative will become a minus. I'm going to put this inside of a bracket. Now the integral again of cosine x is going to be sine x. And we're evaluating this from pi over 2 to pi. Any questions so far? Okay. So let me just put both of these inside of brackets just so that we can stay consistent. Now there is a way to remember how to evaluate sine at pi over 2 and pi. It looks something like this. So I'm going to write this off to the side. So if you're trying to evaluate sine, underneath the I, we'll draw out a rectangular coordinate system. And what, is this wrong? I did. I stole someone's fabulous idea. So to remember this, we're going to draw a rectangular coordinate system underneath our I in sine. Now when you're evaluating it underneath the I, on the other side of our y-axis, we're going to have a negative 1, and on either side of our x-axis, we'll have 0. Now keep in mind, from here to here is going to be at pi over 2. From here to here will be at pi. From here to here will be at 3 pi over 2. And then lastly, will be at 2 pi. So this will become helpful when we're evaluating sine x at pi over 2 and at 0. And you can also use the calculator if you wanted to evaluate this. So to evaluate, we're going to do sine of pi over 2, the upper limit, minus our lower limit, sine of 0. And I'll keep this inside of the brackets. Minus, now let's evaluate the second piece here, sine of pi, let me keep these in parentheses, minus the sine of pi over 2. It's the upper limit minus the lower limit. Now sine of pi over 2, well, sine of pi over 2 is going to be 1. Minus sine of 0, which will be 0. Keeping this inside. Minus sine of pi is going to be 0. Minus pi over 2, which is going to be 1. Now finally, our final answer, 1 minus 0 minus 0, bringing that negative on the inside of our parentheses, we'll have a plus 1. And then lastly, what are we doing? We're just adding 1 plus 1, and we're going to get 2 square units. There's your final answer, 2 square units. Any questions on problem 6? If you'd like me to scroll up, I can scroll up. Yes, what's your question? I'm a little confused on the equation. Okay, let me scroll up a bit so that George can get this. Now, which equation are you confused about? When you're substituting into the integral, how did you get the cosine? Okay, well, when you're trying to find the area bounded by the curves, you're evaluating, what color can I use so that we don't get confused here? Let me do it in gray. So when you're trying to find the area bounded by the curves, you want to evaluate the limit. You want to evaluate the integral of your upper curve minus your lower curve. Now notice that we're trying to find the area of two bounded regions, what I have in green, which means that we're going to be evaluating two different integrals, okay? But it's always going to be the upper curve minus the lower curve. So the first shaded region that I have here, our upper curve is our y equals cosine x. Now, still looking at the first shaded region, our lower curve is going to be y is equal to 0, which is the x-axis. So this is going to be 0. Is that clear? Now, it's the same idea for the second shaded region. So now we're looking here. I'll write that out underneath. So in the second shaded region, we're taking the integral still of the upper curve minus the lower curve. But when you're looking at your second shaded region, our upper curve is y is equal to 0. And now our lower curve is going to be what I have in blue, which is y is equal to cosine x. And the subtraction sign in between. Any other questions on 6? So let me scroll down a bit so that everyone can see the rest of the problem. I suggest that you graph it just so that you can see a visual representation of the problem. If you don't graph it, you probably won't be able to see what your shaded regions will be. So just draw whatever the curves are, and you can also use the calculator. You can put the two curves into the calculator and graph it that way. But because this is a standard cosine curve, that's why I just drew it out the way that I did. You're welcome. So can I move on? Any other questions? Let me scroll down a little bit more so that you see the rest of the problem.
Tell them if they don't remember the sign of the exact angles, they could use their calculator.
And if you don't remember the signs of the exact angles, like what I drew out here, you can always use the calculator and just substitute it into the calculator. All right, I think we're ready to move on to the next one. If you have any other questions, I can always go back at the end. Say 7. Okay, so question 7. We're given the function x to the power of 3 minus 15x squared, and we're asked to find the domain of f of x. That's part A. Well, the domain of f of x, let me write that out. Domain of f of x is actually going to be all real numbers from negative infinity to positive infinity, because our function is a polynomial. Okay, so part A, the domain will be all real numbers because our function is a polynomial. The domains of polynomials will always be from negative infinity to positive infinity. Now part B, the critical values. So to find the critical values, we want to take the first derivative of our function, and we want to set the first derivative equal to 0. So this is what we're going to do. We're going to take the first derivative of our function, and we want to set that equal to 0. This will give us our critical values. So to take the derivative of f of x, what we want to do is we want to use the power rule. So we're going to bring the exponent down in front of our variable, and we want to subtract our exponent by 1. Same thing with the second term. We're going to bring our exponent down in front, and we want to subtract our exponent with 1. Now let's simplify this out. We're going to get 3x squared minus 15 times 2 will give us 30, x to the power of 1. Because 2 minus 1 is 1, but we don't have to put the 1 there. So our derivative is going to be 3x squared minus 30x. Any questions as how we get the derivative? You're just using the power rule. Now what we're going to do is we're going to take the derivative and set it equal to 0, and we're going to solve for x. This will give us our critical values. So to solve this for x, let's take out the greatest common factor, which is 3x. And what we will have left over is x minus 10. Now when we factor, we can set each factor equal to 0 and solve for x to get our critical values. So dividing out by 3, we'll get x is equal to 0, and adding 10 to both sides, we'll get x is equal to 10. So these are our two critical values. Any questions on part B? So for part C, in order to find part C, our maximum and minimum points, we will end up using our critical values. But before we do that, we have to first find our second derivative. So part C, we want to take the second derivative now of our function. And what we're going to do from there is we're going to then substitute our critical values into the second derivative. So let's find the second derivative of our function. Let's refer back to our first derivative. Our first derivative was here. So now let's find our second derivative. Again, using the power rule, we'll bring the exponent down in front and subtract our exponent by 1. Minus 30, our exponent now is going to be a 1, and we're going to subtract our new exponent by 1. Simplifying out, we'll get 6x minus 30. Any questions as to how we get the second derivative? F double prime of x. All right, now let's substitute in our critical values into our second derivative. By doing this, this is going to show us what our max and what our min values will be. So substituting into the second derivative, the first critical value that we got was 0. So we'll substitute 0 into our second derivative, and this will then equal negative 30. Now, since the second derivative evaluated at 0 is less than 0, this tells us that x is equal to 0 will be our max. So any questions as to how we're evaluating x to equal 0 to be our maximum? Now they are asking us for the maximum point and the minimum point. So since we know that x is equal to 0 is where our maximum is going to occur, in order to find our point or our coordinate, we're now going to substitute in 0 back into our original function. So back into our original function. So when we substitute 0 back into our original, this is going to be 0 to the third power minus 15 times 0. So when we evaluate this, our y value is going to be 0. Therefore, in answer to part C, our maximum point occurs at 0, 0. Any questions so far? This is our max. They want the max and the min, so it's kind of the same process, but now we're substituting in 10 into the second derivative. So let's substitute in 10 to our second derivative. So f double prime of 10. Just to check to be sure that it is going to actually give us a minimum. So substituting in 10, 6 times 10 is going to give us 60, and 60 minus 30 will give us a positive 30. Now, because this is going to give us a value that's greater than 0, we can say that x is equal to 10 will be our min, or our minimum value. And the same idea, to get the actual point or the coordinate, we'll substitute 10 back into our original function to get our y value. So when we evaluate 10, 10 to the third power, 10 to the third power, that's going to give us 1,000 minus 1,500. Therefore, our y value will be negative 500. So with that being said, therefore, our minimum point is going to be 10 comma negative 500. And that is our final answer for part C. Are there any questions? I'll give you guys a second to copy it out. Take your time. If I went too fast, I'll just go back. Oh, good. Yeah. Oh, I forgot the squared. I forgot to put the squared. Yes. Because the original function, it was x to the third power minus 15x squared. Yes, you're right. Because f of x is equal to x to the third minus 15x squared. Thank you. Thank you for that correction. Any other questions? Do you need me to scroll up so that you can get the top portion? Will they tell?
Yes, they will tell them if they want them to graph it.
If they ask you to graph it, they'll say it in the problem, but they don't ask us to graph. So for this case, we're not going to graph this. But they could ask you anything on the final. I don't know what they will ask you.
But it will probably be very similar to what's on the review sheet.
Yeah, your final will be very similar to what you have in the review sheet. Any other questions?
Tell them don't ask me specific questions about the final because I don't know.
If you ask me specific questions about the final, I can't answer them because I have no clue. I have no idea. Review the review sheet, go through the problems, look through your notes, and I promise you there'll be no surprises. There will be nothing on the final that you've never done before. So that I can at least answer for you. So can we go on to the next one? All right. So I'm going on to the next one. If you need me to go back, I'll go back. So let's move on to questions 8A and 8B. Okay. So question 8A, we're given dy dx is equal to 5y. Find y given that y is equal to 1 when x is equal to 0 and y is greater than 0. This problem involves separable differential equations. So what we want to do is we want to first cross multiply. Let me write out the problem. Dy dx is equal to 5y. The first thing that we want to do is we want to cross multiply. So when we cross multiply, we get dy is equal to 5y dx. Now keep in mind when we're cross multiplying, if you want, you could put 5y over a 1, and when you cross multiply, you'll get the following result. So when you are solving a separable differential equation, you want your y's with your dy's and your x's with your dx's, okay? So notice that you have dy on the left and y on the right. So what we want to do is we want to get y on the same side as dy. So let's divide both sides out by y. So what we're going to get is we're going to get 1 over y, dy is equal to 5 dx. Any questions so far? Okay, so what we want to do now to both sides of our equation is we want to integrate both sides. By integrating both sides, this will allow us to get our equation in terms of y. Okay? So when we integrate, 1 over y dy. This is a special integral which will equal ln of the absolute value of y is equal to, now when you take the integral of a constant, you're going to take the constant, in this case 5, and you just want to include the variable that you're integrating. And in this case on the right side, we're integrating in terms of x, plus our constant c. So any questions so far? Cross multiplied, you get your y's with the dy's, integrate both sides. 1 over y is a special integral, so we get that absolute value ln y is equal to 5x plus our constant. Now we are given a condition. The condition that we're given is that y is equal to 1 when x is equal to 0 and y is greater than 0. Therefore, what we need to do before we solve for y is we first need to solve for c, our constant. Now, that given condition, y is greater than 0, this will allow us to remove the absolute value symbols around our y. So remove the absolute value symbols around y, and we get ln of y is equal to 5x plus our constant. Now they tell us that y is equal to 1 and x is equal to 0. So let's substitute 1 and 0 into our equation. So ln of 1 is equal to 5 times 0 plus c. Again, we're solving for c. Well, ln of 1 is 0. 5 times 0 is 0. Therefore, c is equal to 0. Keep in mind what the problem is asking you. The problem is asking you to solve for y. So because we know that c is equal to 0, we are now able to solve our equation for y. So are we good so far? So let's answer the question. We have ln of y is equal to 5x plus c. This was the equation that we got after we integrated both sides. Now, since c is 0, we're going to have ln of y is equal to 5x. c is 0, okay? Now, to solve for y, we have to somehow cancel out ln or get rid of ln. To do that, we're going to take both sides of our equation to the base of e. By taking both sides of the equation to the base e, we are able to get rid of the ln, leaving us with y is equal to e to the power of 5x. And that is your final answer. Are there any questions?
Well, C. Oh no.
So I'll give you guys a second to copy out. Am I moving too fast? If I'm moving too fast, please tell me. I'll slow down. Are you guys still with me? I hope so. Yeah, thank you. Thank you. One response. That's great. I should see 37 responses, but it's okay. Quit watching football. What indicates that you need to solve for C? So the reason why that we're solving for C is because we are given the condition. You have an initial condition in this problem. So since we're given the initial condition that y is equal to 1 and x is equal to 0, and y is greater than 0, we have to first solve for C.
There's a specific constant for that initial condition.
There's a specific constant for the given initial condition. So that's why we need to solve for C.
If you were not given the initial condition, then you would find the general form.
If we weren't given the initial condition, which you'll notice in part B, we're not going to be given the initial condition, therefore we can just leave it in terms of C. Okay, so the reason why that we're taking both sides to the base of E is because it's a natural log property. So by taking both sides to the base of E, what's going to happen is ln is going to end up canceling out with the base of E, leaving us with just Y. It's equal to the argument.
Right, but the reason why you're doing that is because you have to solve for the equation in terms of y.
Now the reason why that we're actually taking both sides to the base of E is because we have to solve the equation for Y is equal to our equation.
So it's not good enough to leave it in terms of ln of y. You need to solve for y.
So you can't leave it in terms of ln, you actually have to solve for Y by taking the base of E on both sides. All right, I think we're good for this problem. All right, let's move on to B. Again, if you want me to go back, I'll gladly go back. Okay, so again, here's another separable differential equation. So let me just write the problem out. dy dx is equal to 10x divided by y. Now, just like we did for part A, again, we'll cross multiply. So when we cross multiply, let me just show that we're cross multiplying. We're going to have y dy is equal to 10x dx. Now notice when we cross multiply, we have our y with our dy and we have our x with our dx. Therefore, we don't have to worry about getting our terms together like what we had to do for part A. So we cross multiply. Now let's take the integral of both sides. Okay. Now when we take the integral of y, it's the antiderivative. So when we take the integral of y, when we take the derivative, what do we normally do? We subtract 1 from our exponent. Well, when we take the antiderivative, what we're going to do is we're going to add 1 to our exponent. Now, whatever our exponent is, that's what is going to be placed into our denominator. Is equal to, okay, so now the right side, we have the constant 10. So if you want, you could pull the 10 out of the integral. And the same idea, x to the power of 1, we're going to add 1 to our exponent, and that's going to become our denominator. And we're going to add our constant c. Any questions on the antiderivative? I'm just going to clean this up. So we're going to have 1/2 y to the power of 2 is equal to 10x squared divided by 2 plus c. Now what we can do is we can actually simplify the 2 into the 10. So we're going to have 1/2 y squared is equal to 2 divides into 10 5 times. So we're going to get 5x squared plus c. Now again, they're asking us to solve for y, so we're not done yet. So because we're solving this equation for y, I'm just going to continue on over here. So we have 1/2 y squared is equal to 5x squared plus our constant. Okay. Now because we're solving for y, we want to somehow get rid of the fraction in front of our y squared. So what we're going to do is we're going to multiply both sides out by 2. This will cancel out our fraction, leaving us with y squared is equal to 2, open our set, 5x squared plus our constant. Now on the answer key, I believe it does not express our solution with a set of parentheses. So what I'm going to do is I'm actually going to distribute 2 inside of our parentheses. So we'll have y squared is equal to 2 times 5. So this is going to give me 10x squared. Now 2 times some random constant is still going to leave us with a constant. So 2 times c, some other number, is going to give us another number. So we're just going to leave that in terms of c. Any questions up to here? A constant times another constant is just a constant. Okay, now finally to solve for y, we want to get rid of the squared, so we'll take the square root of both sides. This will cancel out our squared, leaving us with y is equal to plus or minus, please do not forget the plus and minus when you're taking the square root, 10x squared plus a constant. And that is our final answer. Any questions on 8b? I'm shocked. This is good. Either I'm doing something right or you're doing something right. Let's see. Do we have questions here? Let's hope it's this easy. Oh yeah, I hope so too. Going back to 8a in the last review, they gave the answer with plus c. On the answer key for 8a, it does not express the solution with c because we are given an initial condition. So for 8a, your final answer should not be expressed with terms of c. I'm sorry for that confusion, but it should not have been expressed in terms of c because of the initial condition. Your final answer is just y is equal to e to the power of 5x. Yes. Okay, so the question is, when we take the square root, let me just erase what I have in green to show the step that I had there. So when I'm taking the square root here of both sides to cancel out my squared, I can't simplify my radicand. You can't take the square root of 10x squared and you can't take the square root of c. You can't simplify it that way because it's a sum. You can't break up a radicand that's separated by a plus sign. You can only separate your radicand if it's strictly a product. So you can't simplify that anymore. You leave it as is. So why did I multiply by 2 in the end? Okay, so that's referring back to what I have in blue. So let me just erase what I have here in blue. The reason why I'm multiplying by 2 is because I want to somehow get rid of my fraction that's in front of my y squared. So since my fraction is 1 over 2, I want to multiply both sides by my fraction's reciprocal. Now the reciprocal of 1 over 2 is just 2. Now you'll notice when we multiply out by 2, that cancels out the fraction, leaving us with the coefficient of 1, which is what we want. And then when we move on to this step here, what I'm basically doing is I'm just distributing 2 inside of my parentheses just so that I can simplify it. Well, it's not 10x plus c, it's 10x squared plus c. Would it be wrong to just put the half? Would it be wrong to just put the half on the other side? The half? You mean, oh, no. Okay, never. It's Patrick John's got that one, okay? It's quite alright. No worries. No worries, George. Working together. Okay, so any other questions on 8b? Patrick John is going to be answering you, okay? Alright. Wonderful. All right, so let me move on now to 9. Okay, so for this problem, we're dealing with compounded continuously. Okay, we're looking to compound our money continuously. Now, there is a formula that is needed for this problem, and the formula will be A is equal to A sub 0 e to the power of RT. Okay, this is a formula for compounded continuously. A is equal to A sub 0 e to the power of RT. Okay, now let me just write out off to the side what these variables represent. Now, A sub 0 represents what you're going to start off with, your starting amount. Okay, starting amount. R represents our rate, and T represents time, and in this case, we're dealing with it in years, okay? Time in years. And A is equal to our end amount after the time has passed. Okay? Now, what I'm going to do now is I'm going to substitute into my formula. Now, keep in mind that E is not representing a variable. E is actually the form that we're using for compounded continuously. E represents a number. I believe it's 2.7 something something something. Okay, so E is not a variable. E is representing a number. Okay? Now, when we read the problem, they're asking us how many years it will take to double your money if it's invested at 4%. So this 4% here represents our rate. So our rate is 4%. Now, when we're substituting this into our formula, we have to represent our percent as a decimal. So 4% as a decimal will be 0.04, not 0.4. It's a common mistake that students make. 4% changed to a decimal is going to be 0.04. Now, they don't tell us how much we're starting off with. Therefore, A sub 0 will remain the same. T is what we're trying to find. This is going to be our unknown. Now, our end amount is taken, our end amount is taken from this statement here, the fact that we want to double our money. So what we want to do is we want to double what we're starting off with. Now, what are we representing as our starting amount? We're representing that as A sub 0. Okay, now let me just substitute this into my equation. So A is 2 A sub 0 because we're looking to double our starting amount. Our starting amount is A sub 0 e to the power of 0.04, which is our rate, times t. Anyone have any questions up to here? Let me give you guys a second to copy this out. Okay, that's our formula. We're substituting into the formula. And in this problem, we're solving for t. We are not solving for A sub 0. We're solving for t. Okay? Now, notice that we have A sub 0 on both sides of our equation. Now, if you want, you could do this a long ways by dividing out both sides by A sub 0. And because we have the same constant on both sides of our equation, it's going to cancel out. So we're left with 2 is equal to e to the power of 0.04 t. Again, what are we solving for? We're solving for t. Now notice that t is in our exponent. So to get t out of our exponent, what we want to do is we want to take the natural log ln of both sides of our equation. By doing this, this is going to incorporate now the power rule, where our exponent is going to move in front of our natural log.
Okay, but listen, at this point, tell them, remember in the last problem, you raise it to base e because e to the ln and it cancels out. Same thing here, ln e gives you 1.
Okay, so just like in the last problem where we took the base of e to both sides to cancel out the ln, well, what we're going to do here, it's kind of the same idea where we're taking the ln of both sides so that the ln of e can equal 1. So this is what we're going to have now. We're going to have ln 2 is equal to 0.04 t. Our power is moved in front of our log, and ln of e is going to equal 1. So you're basically just multiplying this by a 1. Let me write that note off to the side. ln of e is equal to 1. It's just a property of log, okay? ln of e is equal to 1. So the power moves in front of the natural log, and ln of e is equal to 1, so we really don't need the 1 there, okay? All right, so now to solve for t, what we're going to do is we're going to divide both sides out by 0.04. This will cancel, and we're left with t is equal to ln of 2 divided by 0.04. Now what you want to do is you want to now put this into your calculator. Now be very careful when you're substituting this into your calculator. When you're substituting into the calculator, which I will show you in a minute, when you're substituting into the calculator, when you're evaluating ln of 2, for most calculators it will open up a set of parentheses. So when you hit ln, it's going to open up a set of parentheses. You want to put in your 2, but be sure that you then close your parentheses. Hit your division sign, and you want to put 0.04. If you do not close your parentheses when you're evaluating ln of 2, your calculator is not going to evaluate the fraction that you're actually trying to find. Okay, so let me try and bring up this calculator here. This is my first time working with this calculator, so you're just going to have to bear with me. Okay. All right. Let's see. Is it on? I think it's on. Okay. What is it? 1? Ah, okay. So what are we doing? We're doing ln. Where's ln? I don't know how to use this thing. Oh, there it is. I see it. Okay, sorry. ln. Let me open up a set of parentheses. 2. Let's close that. Divide that by 0.04. Let's see if this works. Fingers crossed. Ah, it worked. Yeah. Ah. Thank you. Thank you. Thank you. Awesome. Okay, so this is our t. Our t is 17.32867. It's a long decimal, right? So if t is equal to 17.328, keep in mind you're dealing with years, you're basically going to then round this up. So this is going to be approximately 18 years. So that's our answer, 18 years. So any questions on 9? Thank you, Vishwan. Thank you. That's okay. Okay, so the reason why that we're rounding up is because you're not getting the exact value here. The solution that you get when you substitute into the calculator is 17.328. Now, 0.328, that could represent anything. That could represent days, that could represent hours, that could represent months. You don't know. So just to be safe, you want to round it up to 18 years. If you round it down, then that means that you're not going to have the total double amount that you started off with. You're going to actually have less than that. So you always want to round up because the solution is asking you for double the money. So by rounding up, you're making sure that you're going to make double of your money. It takes more than 17 years to make double your money. So that's why you have to round it up. So the question is asking us for double our money. So we solve it out for t. We get 17.328 years. Now, if you're going to round this down to just 17 years, you're not going to make double your money because you have less time if you're rounding down. You're not going to make double your money. Okay? If you're rounding up, you're going to be sure that you're making double your money. Okay. So any other questions? Okay, so just to be clear, it's going to take 17 years and 0.328 of a year to make double your money.
That's more than 17 years.
Okay, which means that this is more than 17 years. This is going to be, this has to then change to 18 years. They're they're asking for the nearest whole year. They don't want it represented in decimals. All right. So moving on to 10. Okay. All right, 10. So in 10, square quarters are cut from a 12 meter by 12 meter piece of tin. All right, so let's draw out the tin. And a tin is 12 meters by 12 meters. And square corners are cut from it. So I'm just going to draw out the tin with the corners that are going to be cut. And what we want to do when we cut out the corners is we want to fold this up and create a box. So our box will look something like this. I'm going to do my best to draw this out. So our tin, 12 meters by 12 meters, our corners are going to get cut so that we can form a box. And the box is going to look something like this. Okay. Now, if we're going to cut out the corners from the box, our length and our width and our height is going to change. Now, because we do not know the dimensions of the box, the corners that we're cutting out, it's going to be a length of x. Now, the problem is asking us for the volume. Now, volume is equal to length times width times our height. So the height of our box is going to be the length of the cube or the square that's being cut out of the tin. The length and the width is going to be represented by 12 minus 2 times x. Now, where am I getting that from? Well, the full length of the tin is 12 meters. If we're going to remove a length of x, whoops, if we're going to remove a length of x here and a length of x here, our side of our box is going to be 12 minus 2x. Same thing here. This is going to be 12 minus 2x. Any questions so far? I'm just showing the dimensions of the box. So the length, the width, and the height, I'll write that off to the side. The length is going to be 12 minus 2x. The width is going to be 12 minus 2x. And the height is going to be just x. Alright, so what I'm going to do now is I'm going to substitute these dimensions into our volume formula. Now, why are we dealing with volume? Because the problem is asking us for the maximum volume. On the test, do we have to draw the box? No, I'm just drawing it out just to show visually what we're doing. If you're a visual learner and you want to draw it out, you can easily draw it out. It's completely up to you. Okay. It's easier to see and work out the problem if you draw out the picture. So substituting in to the volume. So our volume, v of x, okay, I'm using this as a function. Our length is 12 minus 2x. Our width, 12 minus 2x. Times our height, x. Okay? Now what I'm going to do is I'm just going to distribute and simplify the function for volume. So the first thing I'm going to do is I'm going to distribute or FOIL out my two binomials, like so. So 12 times 12 is 144. 12 times 2, this will give me negative 24x. Negative 2x times 12, again, negative 24x. And negative 2x times negative 2x is going to be a positive 4x squared. Now this is inside of parentheses, and don't forget we still have the height x to multiply with it. Again, continuing and simplifying. 144, negative 24x, that's going to combine, and that's going to give us negative 48x plus 4x squared, and we're multiplying that by x. Now again, getting rid of our parentheses, our function. Let's distribute now x into our parentheses. Now it's important that you express your function in descending order. Therefore, I'm going to write this out as 4x to the power of 3 minus 48x squared plus 144x. And that's our volume function. Any questions so far? I have not even answered part A yet. Remind us how you got the 2. Okay, so to get the 2x, I'm guessing that you're referring to this here. The reason why that this is a 2x is because when you have your tin and you're cutting out your corners, on either side of your tin, you're going to have two corners that you're taking out. Two corners with a length of x that's going to be taken out. Therefore, x plus x is going to give us our 2x. And it gets subtracted by the total length of our tin, and the total length of the tin is 12 meters. So when you end up folding back our tin, okay, when you're folding up your sides, your height here is the length of the corner that you're taking out. So that's how we get the height to be x. It's not always going to be minus 2x. It depends on the problem. So because they're telling us in the problem that the square corners are being cut from 12 meters by 12 meters, you're going to take that square corner to be represented by a length of x, because it's just what's being worded in the problem. Depends on what the problem question asks you. Any other problems? All right, so we good? Can I continue on with actually answering the problem now? Okay, so let's go on to part A. Okay, let's actually answer this problem. So the question asks us what dimensions will yield the maximum volume. So to determine our maximum volume, what we need to do is we need to take the first derivative of the function, and we want to set the first derivative equal to 0. By doing this, we're going to get our critical values, and from the critical values, we can determine what our maximum volume will be. All right. So let's take the first derivative of the volume function. Again, to take the derivative, we're going to use the power rule. So what we're going to do is we're going to bring the exponent down in front. So 4 times 3, x to the power of 3 minus 1, minus 48 times 2, x to the power of 2 minus 1, plus 144 times 1. Now when we bring that exponent down in front, and 1 minus 1 is going to give us 0, our x term will reduce to 1, so we're just left with 144. So still working this out, I'm just going to simplify and multiply. So we'll get 12x squared minus 96x plus 144. So this is our first derivative. And we want to now set our first derivative equal to 0 so that we can get our critical values. And from the critical values, we can determine what our maximum and our minimum will be. Now notice that you're actually able to take out a greatest common factor. It's always important to look for a GCF before you begin to factor. So when we take 12 out, we're going to be left with x squared minus 8x plus 12. Now by factoring, continuing, open up 2 sets of parentheses. We're going to have x and x. Our signs will both be negatives. Factors of 12 that will give us an 8 will be 6 and 2. Now to get our critical values, we want to set our factors equal to 0. Now by setting 12 equal to 0, this is not going to give us a solution. So this is going to end up being rejected. Now we'll take x minus 6, set that equal to 0, x minus 2, and set that equal to 0. So our two critical values will be x is equal to 6 and x is equal to 2. Okay, these are only our critical values. Okay, so now what we want to do is we want to test our critical values in the second derivative to determine what will be our maximum value. So let's now take the second derivative of our function. So we'll take the second derivative. Now what was our first derivative? Our first derivative was found here. So now we want to take the second derivative. So bringing the exponent down in front using the power rule, 2 minus 1, minus 96, bringing the exponent down in front using the power rule, subtracting 1 from the exponent, so the x is going to drop out, and the derivative of a constant is going to give us 0. So simplifying this out, this is going to give us 24x minus 96. Okay, this is our second derivative. Now what we want to do is we want to test both of our critical values in the second derivative to determine which one is going to give us our max. Okay, so the first value that we got, the first critical value that we got was x is equal to 6. So let's substitute 6 in the second derivative. So we're going to do 24 times 6 minus 96. Now when you evaluate this, 24 times 6 minus 96, this is going to give us a positive 48. 48, which is greater than 0. So because our second derivative evaluated at x is equal to 6 is greater than 0, x is equal to 6 is our minimum value. Now the problem does not ask us for a minimum. The problem is asking us for a max. So x is equal to 6 is not going to give us our maximum value. So what we want to do is we want to now test to see if 2 will give us our maximum value. So 24 times 2 minus 96. So 24 times 2 minus 96, this will give us a negative 24, which is less than 0. Therefore, at x is equal to 2, we will have our maximum value, which is what we want. This is what the problem is asking us. Okay, so this will be our maximum value when x is equal to 2. Okay, when x is equal to 2. Now, I believe, just let me scroll up for a second. Actually, I don't have to because I have the questions here. Okay. So for part A, the question asks us for the dimensions which will yield a maximum volume. So keep in mind, what were our dimensions? Our length was 12 minus 2x. Our width was 12 minus 2x. And our height was x. Now the value that will give us a maximum is 2. The value that will give us a maximum is when x is equal to 2. So what we want to do is we want to now substitute 2 into our dimensions. So 12 minus 4, this is going to give us 8 meters. Substituting in for 2 for the width, again, will give us 8 meters. And our height, which is just a variable x, this is going to give us 2 meters. So these are our dimensions for part A of our box. Any questions on part A? Okay, just give me 1 second so that I can look through the questions here. Now you got a negative 48 instead of a negative 24. Oh, I must have made a mistake with my calculations here. Okay, let's see. So when I multiply this out, this gives us a 48 minus 96. It is, okay, so this is going to give us a negative 48. My bad, my bad. Sorry. Thank you, thank you for correcting my mathematical error. It should be negative 48, not negative 24. Okay. So now we have a question here as why is the negative sign representing our maximum value? Yeah.
How to use the second derivative test for max or min. So explain to them that if the second derivative is positive at the critical point, that means your graph is concave up. Therefore, a minimum
Okay, so when you're using the second derivative test to determine the max and the min, okay, you have to determine when your second derivative is positive. So when the second derivative is positive, that means that you're going to be at concave up, which means that at that value, you're going to have a minimum. Yeah. And when you're using the second derivative and substituting in, and you see that the second derivative is a negative number, this means that this is concave down. Therefore, that will give you your maximum value. Is the mic on? Yeah. Oh, yes, the mic is on. No, the mic is on. I thought I switched it off. Did you guys hear that? So you're using the second derivative test to determine max and min. So when you find that the second derivative is a positive number, that means that you are concave up. So at that value, at that critical value, you will have a minimum. Okay? Now, if you're using the second derivative and it ends up being negative, that means that you are concave down. So at that critical value, it will be a maximum. Any other questions on 10? This is only part A. I didn't even answer part B yet. Well, part B is not too difficult. All we have to do is just calculate the volume by multiplying out our dimensions. If we do not show the work for this V. Well, you have to show the work for the second derivative, V double prime, because that's the way that you're testing whether it's your critical values are a max or a min. So you have to show all work. Okay? Show as much work as you can. This is your final. Okay? Show everything. Draw pictures. That's the way that you're going to determine your max and your min by taking this V double prime. Any other questions on part A? Okay, so just finally, to answer part B, they're asking us to find the maximum volume. So to find part B, or to answer part B, you want to use the dimensions that you had found for part A. Now, our dimensions, length times width times height, our dimensions was 8 meters times 8 meters times 2 meters. So when we multiply this out, 8 times 8 times 2, we're going to get 128 meters cubed. 128 meters cubed. So that is our answer for part B. Any questions? The mouse. Put off to the side. So we good for 10? Do you need me to scroll up? Maybe you need to see what's up at the top. I think I could scroll up a little bit without cutting anything off. Alright, well this was the last problem. So if anyone needs me to go back, I can go back. Are there any questions? Six, okay. Okay, a lot of people want 6. Okay, I can go back to 6. Whoa, okay. Yes. Okay, let's go back to 6. Okay. Okay. Hey guys, if you have any questions, please do not raise your hand. That's not going to help me. You need to write out the question in the Q&A box so that I know. All right. I'm going to erase this stuff and I'm going to do it from the beginning, okay? We have the time, so let me just delete all of this. Just give me a second. Just bear with me.
You know what it is? They're having problems identifying the top and bottom of the region. Outline it like this and say this is the area, this is the top, this is the bottom, that's the tube. You know.
I'm gonna highlight it a little differently this time. This way you guys can see the upper and the lower curves. Okay. All right. So let's go through 6 again. So we have two curves. Y is equal to cosine x and the x-axis, and we want to find the area bounded by both of these curves. So let me first draw out the rectangular coordinate system, and I'm going to draw out y is equal to cosine x. Now y is equal to cosine x. I'm going to draw this out in blue. And the x-axis, okay. But first let me write out my values for x with my cosine curve. So my values for x will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now I'm getting these values because the curve is y is equal to cosine of x, and this is a standard cosine curve. So that's why our x values are the following. Okay, this is my x-axis, this is my y-axis. Now we're also given another curve, the x-axis. Now the x-axis is where y is equal to 0. So I'm going to show that in red. So this is the x-axis, y is equal to 0. Okay? Now we're looking for the area bounded by the curve from 0. Let's see, can I use this? Okay. We're looking for the area bounded by the curve from 0 here to pi here. Now what I'm going to do is I'm just going to drop a dotted line through pi so that we can identify the area that we're looking for. So we're looking for the area bounded by the curves here, what I'm shading in green, and also here. Any questions as to how I'm identifying my shaded regions? Now I am going to label my two shaded regions. This is my first shaded region, and this is going to be my second shaded region. The reason why I'm identifying both of them is because in order to find the area of a shaded region, you want to take the integral of the upper curve minus your lower curve. Now wait, I have a question. Okay, so the question is, why are we identifying the first shaded region? Well, in the first shaded region, it's the area bounded by the curve. Y is equal to cosine x, so I'm just highlighting that in blue, and the x-axis. So that area is what's here. Is that clear?
You need to know the curve.
Now the second shaded region, just to identify it, okay, it's the area bounded by the y-axis, which is what I have in red, and the cosine curve, which is what I have in blue, but it has to stop at pi. Now, why are we stopping at pi? Because we're told the area is between 0 and pi. So that's why we're getting this second shaded region here. Now, I also received a question as to how do I get the intersection to be at pi over 2? Well, you have to know the values for x for your cosine curve when y is equal to cosine x. You have to know those values, okay? Now, to find the area bounded by our curve, so what I have in green, you want to take the integral of your upper curve minus your lower curve. Okay? Now keep in mind we have two green shaded regions, therefore we're going to have two separate integrals. Okay, and we're going to add them up. So just to write it out, we're going to have the integral of the upper curve minus the lower curve.
You can label this like 1.
Yeah.
Roman numeral 1, like region 1.
Yeah. So just let me write this out neater. Okay, so this is going to be the upper curve minus the lower curve.
Put a 1 above.
Now this is representing our first shaded region, so I'm just going to identify this as Roman numeral 1, plus the integral of now the second shaded region, still going to be the upper curve minus the lower curve. Again, this is representing Roman numeral 2. With me so far? All right, I'm just going to erase the shading just so when I identify my upper and lower. Okay, so identifying in the first shaded region, what we had here, it's the integral of the upper minus the lower. Now, what's our upper curve in the first shaded region? Our upper curve is what I have in blue, our cosine. So this is going to be cosine x minus the lower curve. So in the first shaded region, our lower curve is going to be y is equal to 0, which is what I have in red. So therefore, it's going to be cosine x minus 0. Well, yeah, you could, I guess. If you want, you could put this in parentheses and put dx there and put dx there. So keeping consistent, upper minus the lower, parentheses dx. Now, you are evaluating this integral. Where are you evaluating this integral? You're evaluating this integral from 0 to pi over 2. So any questions in identifying the first shaded region? Let me just clear that. It looks a little sloppy. Pi over 2. Okay, now we'll take the integral of the second shaded region, Roman numeral 2. Now what's our upper curve in the second shaded region? Our upper curve is now y is equal to 0 minus the lower curve, which is now cosine x, what we have in blue. Again, this is in parentheses. We're evaluating this with the dx. Now, what will our conditions be? Now we're taking the second Roman numeral from pi over 2 to pi. So that's what we're going to evaluate our integral at, from pi over 2 to pi. Any questions so far? All right, let's simplify. So we have the integral from 0 to pi over 2 cosine x dx plus the integral of pi over 2 to pi of negative cosine x dx. Okay? Now let's evaluate our integral. Our integral for cosine x, our antiderivative of cosine x, is going to be sine x. Now I had this in brackets before, and we're evaluating sine x from 0 to pi over 2. Plus, well now, is it going to be a plus? No, it's not going to be a plus. It's actually going to be a minus. Now, how are we changing this to a subtraction sign? You're taking the integral of negative cosine x dx. So this negative sign is going to come outside of our integral. Therefore, it's going to be minus. Antiderivative of cosine is going to be sine x. And we're evaluating this from pi over 2 to pi. Just going to scroll down a bit. With me? Now we'll evaluate. So evaluating sine x from the upper limit, pi over 2, minus the lower limit, sine of 0, and we had that in brackets, minus evaluating the limit from sine upper limit of pi minus the sine of the lower limit, pi over 2. Now you can use a calculator to evaluate sine of pi over 2, sine of 0, sine of pi, or you can remember the following. So you can draw a rectangular coordinate system underneath the eye of sine. So you're going to write out the word sine, draw out a rectangular coordinate system underneath the eye. Now on the other side of your y-axis you'll have -1, and on either side of the x-axis you'll be at 0. Okay? Now, based off of our quadrants, this is going to be 90 degrees, pi over 2, 180, which is pi, 3 pi over 2, 270, and then lastly 2 pi. So when we evaluate sine of pi over 2, sine of pi over 2 is going to give me 1, minus the sine of 0. Sine of 0 is going to just give me 0, minus sine of pi is 0, minus sine of pi over 2, which is 1. Now this is going to give me 1 minus 0 plus 1, which is equal to 2 square units. And that's the answer for 6. So any other questions on 6?
Don't even bother. But somebody wanted to go over number 9.
All right, so let's move on to 9. Somebody wanted to see 9. Can I move on to 9? I know someone wanted to see 9. All right. 9. All right, 9. All right, so for 9, we're dealing with compounded continuously. All right, let me just clear this out. Was there a specific question that you wanted answered about 9? Okay, so for 9, because we're dealing with compounded continuously, we want to use the formula A is equal to A sub 0 e to the power of RT. Now let's identify what these values represent. A sub 0 represents your starting amount. R represents our rate, and T represents time in years. Okay. And A represents your ending amount. So how much you're going to end up with after T time has passed. So our starting amount, which we don't know, we're not told what our starting amount is. Therefore, A sub 0 will remain the same. Our rate, which is 4%, we want to convert into a decimal. Okay? You can never use the formula dealing with a percentage, so you want to convert your percent into a decimal, which will give us 0.04. Now, time in years, the time we do not know, that's going to equal T. And our ending amount, we want to actually double what we started with. So our ending amount A will be represented as 2 a sub 0, 2 times our starting amount. We'll substitute in. So this is going to give me 2a sub 0 is equal to a sub 0 e to the power of 0.04 t. Now notice that you have the same variable on both sides, a sub 0. So what's going to happen here is a sub 0 is going to cancel out. So we're left with 2 is equal to e to the power of 0.04 t. Now because the variable that we're solving for is in our exponent, we want to take the ln, natural log, of both sides of our equation so that we can bring down our exponent to the front. Now when we bring our exponent 0.04t in the front of our natural log, ln of e is going to equal then 1. It's a property of log. ln of e is equal to 1. So our base e basically is going to drop out. Now to solve for t, we're going to then divide both sides by 0.04. Therefore, t is going to equal, it's going to actually give us a decimal. It's going to give us 17.328 years. Okay? Now, they want to know how long it's going to take to double our money. It's not going to take 17.328 years because they're asking us to round this to the nearest whole year. Now, when you round this to the nearest whole year, it's not going to give us 17 years. It's actually going to give us 18 years. If you round it down to give you 17, then that means that you're not actually going to double your money. You're going to have less. So we have to round up to 18 years. So t is equal to 18. Any questions on 9? It depends on the question. If they're asking us for how long it takes to double your money, you can't round it down. If you're rounding it down, you're not going to double your money. Depends on what the question is asking you.
It takes more time to do something. They may ask you for the exact value and not to round at all. I don't know. I love them. Are they always going to do that? Just do that?
Any other questions?
A or B? What was 8? Oh, that's the different, the separable difference.
Which one do you want? Whichever one that you want. Doesn't make a difference to me. Either one. All right, so then we'll do 8B. All right. All right, so let me just clear this out. All right. So 8B and even 8A, it involves a separable differential equation. So what we want to do is we want to cross multiply, and we're going to get y dy is equal to 10x dx. Now, when you're dealing with a separable differential equation, you want your y's with your dy's and your x's with your dx's. Now, when you're doing 8a, you'll notice that your y's are not going to be with your dy. So what you would then have to do is you would have to move your y over to the other side. Is that understood? So for this problem, we don't have to worry about moving anything because our variables are with dy and our variables with dx. Our y is with dy, our x is with dx. So to solve for y, what we want to do is we want to integrate both sides. So when we integrate y dy, it's the antiderivative. So instead of subtracting 1, we're actually going to be adding 1 to our exponent. And whatever you have in your exponent, that's going to become your denominator. Now, we have a coefficient in front of our variable with our x. So this is just going to become 10x, 1 plus 1, divided by our exponent, 1 plus 1, plus our constant c. Now, just to simplify, this is going to be 1/2 y squared is equal to 10x squared divided by 2 plus our constant c. Simplifying 2 into 10, we'll have 1/2 y squared is equal to 5x squared plus our constant. Are you with me so far? All right, so because we're solving for y, what we need to do is we need to get rid of the fraction that's in front of our variable. So to get rid of the fraction, we want to multiply both sides by its reciprocal. Now the reciprocal of 1/2 is the whole number 2. By multiplying both sides out by 2, this will cancel out our fraction or reduce our fraction to 1. Therefore, we'll end up with y squared is equal to 2 times 5x squared plus our constant c. Now, in our final answer is not expressed with a set of parentheses, so we'll distribute 2 to get rid of our parentheses, and I'm going to finish this problem off over to the right. So when we distribute 2, we're going to get 10x squared. Now, 2 times our constant c is just going to multiply and give us another constant, which we'll label as c. So when we're multiplying 2 times c, a number times another number, it's just going to multiply and give you another number. So we're representing that number as c. Now we're almost done. We have y squared. We want to solve this for y, so we'll take the square root of both sides to cancel out our square. Therefore, we'll be left with y is equal to plus or minus, okay, don't forget the plus and minus, the square root of 10x squared plus our constant c. And that is your final answer. Any questions? Is that clear? Any questions? Oh, you're welcome. All right, well, if you guys have no other questions, that will conclude the review for tonight. If you have any additional questions, feel free to stop in the Math Center. Your test is tomorrow at 10 o'clock. So the Math Center opens at 9. So if you need any help, shoot over to the Math Center at 9 o'clock. All right? If you want to see me, I will be around, so you can always just meet with me. Okay? What do you mean you only have 1 hour to study? You should have been studying this whole time. 1 hour to study. My goodness gracious, that's nails on a chalkboard for a teacher. Come on now, you're making my ears bleed. 1 hour to study. Start studying now. Well, yeah, so basically for 8A, you're doing the same thing. You have to divide both sides out by y, okay? You're going to divide both sides by y. But notice in 8A, you don't have an x, okay? You're just left with a constant of 5. Okay, you won't have an x in that problem. So you divide, let me just bring it up. You know what, let me just show you. Okay, so we cross multiply, okay? When we cross multiply, we have to divide both sides out by y, all right? So we're taking the integral of 1 over y dy is equal to the integral of 5 dx, okay? So you're taking the integral of this. But for 8a, we're given an initial condition. So because we're given an initial condition in this problem, we have to first find and solve for c. Okay, so let me just scroll down. So what I did here was I took the integral of both sides and then I solved it for c when I was given the initial condition of y is equal to 1 and x is equal to 0. So when I get my value for c, I'm going to plug it into my equation and I'm going to now solve that equation for y, which is what they ask us for. Okay. We're not doing that in 8b because we are not given an initial condition. Therefore, we can leave the equation in terms of c. Okay, that's going to be somebody's typing to you right now, okay? So Johnny, did you understand that, what I was talking about with 8a? Okay, good. Okay, let me leave this up for a second. You're welcome. No problem.
Question number 3. Which one was that?
Let me see. All right, so we have one question that we're going to go through, and then this will conclude the review for tonight. Let's go through question 3, okay, from yesterday's review. We're going to go through question 3 from yesterday's review. All right. And then we'll conclude with this, okay? So the question asks us to find the values of x where the tangent is horizontal. Now, it's important to remember that horizontal tangent lines, the slope of tangent lines are equal to the derivative of your function. Okay? Now, they're telling us that the tangent that we're dealing with is horizontal. So the slope of a horizontal line is equal to 0. Therefore, we're going to take the first derivative of our function and we want to set this equal to 0. Okay? So we're going to take the first derivative of our function. We want to set this equal to 0. We're setting it equal to 0 because we are told that the tangent we are dealing with is a horizontal line, and slopes of horizontal lines are 0. Okay? So let's take the first derivative of the function. So the first derivative of the function, we're bringing the 3 down in front. We're bringing the 3 down in front, subtracting our exponent by 1. So this is going to become a 3 minus 1, which is 2. Minus 3 times 2. 2 minus 1 is going to give us 1. And the derivative of constant 5 is 0. So we want to set this equal to 0. So we're going to get 3x squared minus 6x is equal to 0. Any questions up until here? So slope of tangent lines is equal to the first derivative of the function. We're told that the tangent is horizontal and the slope of a horizontal line is 0. Therefore, we're taking the first derivative and setting it equal to 0. Now what we want to do is we want to solve this equation for x. This is going to give us our x values. So let's factor out 3x, and we're left with 3x minus 2 is equal to 0. Setting both of our factors equal to 0. And we're going to get x is equal to 0 and x is equal to 2. So what these values represent, these are the x values. These are the x values of the point that our tangent passes through. I'm just writing this down. These are the x values of the point that our tangent passes through. Now, what we want to do is we want to find our y values now. We want to find the y values of our point. So to find the y values, what we want to do is we want to substitute x to be 0 and x to be 2 back into our original function. Okay? So substituting x to be 0 into our original function, this is going to be 0 to the third minus 3 times 0 squared minus 5 is equal to negative 5. So what did this just tell us? This tells us that the point where the tangent passes is at 0, negative 5. Now we're going to do the same thing when x is 2. So substituting in 2, 2 squared minus 5. So 2 to the third power, that's 8. 2 squared is 4. 4 times 3 is 12. So we get our y value to be negative 9. Therefore, the point that the tangent passes through will be 2, negative 9. Now, to finally answer the question asks us for the equation. Now, keep in mind, equations of horizontal lines that pass through the point a comma b will have the equation of y is equal to your y value or your b of the point that your line is passing through. So with that being said, our equation for our horizontal tangent line that passes through the point 0, negative 5 will be y is equal to negative 5. And the equation here will be y is equal to negative 9. And that is our answer. Are there any questions on 3?
I don't have any questions.
Oh, you're welcome. No problem. All right, so that will conclude the review for tonight. Good luck. Get a good night's rest. Make sure you have breakfast in the morning. Um, study. Okay. If you have any questions, just feel free to stop into the math center tomorrow morning. Okay. Alrighty. So you're welcome. Have a wonderful night. Continue studying.